you want me to blur? Do you want me to blur the background, or is it
No,
okay? Let
background's
me
fine.
know
Yeah,
what you want to do.
I'm pretty low tech on my channel. It's just basically talking head stuff, so I don't do a lot of production or anything. So on my own. So
That's cool. Great.
yeah, it's good that I got a hold of you today. So I guess I'll just start in. Dave Dickinson, freelance writer for Sky and Telescope and Universe Today, and I am covering the launch of the Nancy Grace Roman Space Telescope coming up Saturday or Sunday, Sunday morning, August 30th. And I have with me today Bear Witherspoon, who is the NASA Roman Payload Systems engineer for the mission. So and we're going to ask a few questions here. So, hey, Bear, how you doing?
Happy to be here. Go
Yeah,
Roman.
very cool. Yeah, I know. It's amazing they're getting this one off early. I've been writing about it, and it's for a few years now,
Yes.
off and on, like as it's progressing, and they're actually
Right.
getting this mission off.
Yep.
That's rare. Usually, I remember James Webb. We followed that for it seemed like launching next year, James Webb, and that was like every year for about 5 or 6 years. It kept getting bumped.
Yep.
So
Yeah.
so
Yep.
so
Yes.
what's unique about Nancy Grace Roman versus say Hubble or James or JWST?
Well, no, that's a great question. The Our superpower that we have going on is that we're going to have this immensely large field of view on our camera, our primary instrument, where we're going to be surveying. That's sort of the line, right? Surveying large swaths of the sky, and then repeatedly doing so, right? And so, what that means is that, and then massive amounts of data come down and we give it to the world. And essentially we say, hey, is there anything in these reams and reams and reams of data that you would like to look at differently? Say in a different wavelength, you can use Hubble to look at it in the visible, or would you like to look at it, say, back to the dawn of the universe? Let's pull out James Webb and use its much sharper focused and deeper field of view. So it's kind of a beautiful thing that all of them are going to get to work together in the sky because they're different tools in your toolkit. They do different things.
Yeah, I'm to
Does
understand
that help?
like yes, it does actually. For Vera Rubin, like Vera Rubin and LSST, Nancy Grace Roman's going to generate a lot of data, from what I understand.
Absolutely. So there's going to be 1.4 terabytes of data coming down every day. One of my colleagues, his good analogy that I'll steal right now blatantly is it's like I was going to listen to a million songs a day,
Wow.
which is more songs than I'll ever listen to in my entire life, right? Over the course of the 5-year mission, it's going to be 20,000 terabits, and that's I did a little sleuthing. That's the equivalent to 67 Spotify's,
Wow.
right? And that's over the first 5 years, right? That's the first 5 years, and then I'm sure the mission will end up lasting a bit longer than that. But that's the what we always promise is 5 years, and then we see what happens after that.
And is this going to be available for the public to comb through?
Oh, absolutely. The scientific community has been spending tons of time ahead of time to both develop the tools and the platforms for anyone who's interested to come in and start diving into the data. So you don't have to be an incredible astronomer at the best university in the land here. You can get on these websites and you can just dive right in and start looking for whatever you want to find. So yeah.
I think it's they're calling it Roman Nexus, I believe. This is the network they're setting up
Yes. No, you got
for
it.
that.
That's it. That's it. Thank you.
Yeah, yeah. It's so you think there'll be any surreptitious discoveries like comets or asteroids or anything that it's not looking for that will still come across?
Absolutely. Because again, we're covering so much of the sky and billions of galaxies, let's just say, right? And stars, et cetera, et cetera. Um, that means we're going to find thousands of one in a million type things, right? We,
Wow.
we have no we have no idea what the surprises are that are about to unfold, right? And that's what's super exciting. I mean, we're going to be doing stuff that, they're the mission objectives, right? Or we're going to do a demographic census of the exoplanets in the Milky Way, right? We're going to be trying to shed some light on these mysterious things called dark energy and dark matter, right? We're also going to be performing a tech demo, which is it's a special type of technology that we really want to use in future missions, like the Habitable Worlds Observatory, is that new coronagraph that we're coming out
Yes.
with, which is a direct imager of exoplanets, right? So those are the things that are like on the tin, on the list of the mission objectives, right? But then it's just like there's so much with this treasure trove of data. Who knows what's in there, right?
I,
So Hubble resolution images of massive swaths of the sky.
I'm to understand the coronagraph. Well, it's not planned to do terrestrial exoplanets, like Earth-sized exoplanets. But I mean, it's not planned to anyway. But it's more of a demonstrator.
Not planned to. Right. It's a demonstrator because what this is we are going to be with our primary imager, we're doing a lot of exoplanet discovery as well. This tech demo is demonstrating a specific type of coronography, which coronography, right, is like everybody's held up their hand to block out a street light and then try to see something faint that's around it, right? That's coronography. It's blocking out the star to try to look at the faint exoplanets around it. But we're doing it with like commands from the ground to deformable mirrors to make the brightest thing in the middle of that image a dark hole. It's called digging a dark hole, so that you can see the faint stuff around it, so you can directly image those faint things. And so that is the special, from a million miles away, right? It's going to be out at L2, and
Yeah.
gonna we're gonna use it this way. So pretty neat.
I'm to understand that
Sorry.
if it's successful, the coronagraph they'll keep doing science operations with it, even though it's a demonstrator. They'll use it for a while. They can.
All of these things, it's up there. It took a lot of effort to get it up there.
Yeah.
So we will squeak out wring out every little bit of juice that you have in that in that in that lemon, or whatever you want to call it. Not calling it a coronagraph a lemon. You know what I'm trying to
Yeah.
say.
Yeah.
So yeah.
So I'm to understand, and I remember we all wrote about this. I believe it was 2011, 2012, when this is built
Mhm.
around one of two mirrors that the National Reconnaissance Office donated to NASA, and it's always amazing to
Right.
me to think that the NRO has just these Hubble class mirrors that are laying around, like to kind of hand off. Um, is and I was to understand this mirror was actually a boon for it, was that it was bigger than what they wanted to do for what was I'm losing it now. The Roman was it's like the dark energy mission they wanted to do originally.
Yeah. So that's all good background. Yes, it's like donating a telescope from a different agency, but then there's tons of work that go into, okay, we've got this optic, wonderful, but we need to shape it and polish it so it actually does what we want it to do. Instead of being earth facing, we want it to be right. So it's and you have to add on a bunch of let's say additional optics to feed the two cameras the specific channels that are on our space telescope. So although yes, we did receive that donation, it wasn't without work behind it. It was like, oh, free
Yeah.
telescope, there you go, you're done. It's like, no, there's
Yeah.
quite a bit more to be done there. Yeah.
Yeah, I was always curious, is like, was it easier? Did it actually boost doing this mission to have a mirror already? Like you were saying, there's still a lot of work because you have the mirror. There's still a lot of things that had to be done. But did that make things any easier, or it's kind of like building a house versus modifying a house. Sometimes it turns out to be more work.
Right. And it it's a great question. It's hard to tell, right? Because there's
Yeah.
so many other things that are involved in these types of projects, right? It's like one of the things that might help sell it or get it, funded fully was like, oh, and we have this thing that we already have to start working with. And then it gets people behind the mission be like, oh, great, there's some foot, there's a leg up already. Like, let's get going on that one. Right. So,
Yeah.
or, right. So it's kind of it's hard to say, right? It's
Yeah.
hard to say. It was a different prescription than the original mission was designed for, but then we just worked with what we had and got to take that exquisite piece of hardware and make it ours.
Did they ever find a use for the second mirror? I have not seen any talk about. I don't know if you know that. Like, is it?
I don't. That's that I don't know if that's above my pay grade or just like
Yeah.
outside of my world, right? Like I'm focused on the inside of the mission. I honestly don't know. I do know there was a second one, but I don't know anything more than that. So I think we're on the
I
same footing
I know
there.
when you look online, you see some very rough ideas, but there's nothing. There's no firm proposal that I've
Okay.
heard anyway.
Yeah.
But it's kind of
Yeah.
it's like I would be
Yeah.
interested to know. Do you know it was very
Of
interesting
course.
that they're launching this early, and that's really unique among, like we said, the
Yeah.
James Webb Space Telescope was almost epically delayed for years and years before it finally went. Uh, do you know if there was any decision to drive? There was any decision that drove that to say let's launch? Like it all just kind of came up. All of us we were all thinking everything you saw online was like early 2027, and then suddenly it's like no, they're launching in August. I was like, I'm just interested if
Right.
anything drove that.
Right. Well, I mean, it's kind of wild to think about, right? Because the launch date changed a little bit over time because of COVID and the like, things like that,
Yes.
and moved around a little bit. But then we're actually earlier than those original pre-COVID estimates, right? So that's why we're saying we're quite early, largely just because, how do you put this? Open, honest communication from both project management, our subcontractors, all of the people on the technical side of the team as well. Everybody was just on it and willing to bring their issues if they had them to the fore. And so, like, we need to work these out, right? Everything had to be that way, especially during the pandemic when people are at home and we're still pushing ahead with everything. You just had to be an open, honest, good, gelled team to just keep stuff pushing forward. And that, I mean, there's also a lot of, let's just say, enthusiasm amongst our people to like push, push, and get it done.
Yeah.
And make sure that we get to launch this into space and go for it. So it's been a hell of a ride, I will say, just because it is intense to push this hard, but we just a lot of drive, if that makes sense.
Yeah, no, it's amazing, and it's very cool that we're getting it off this early. That's kind of an extra present. What's the
Yeah,
timeline? When should we expect to see the first? Probably going to be, I think it's 30 days to get to L2, Lagrange point two, the Earth's on L2. When should we expect to see
it's
the
a bit
first
longer,
images,
but
science?
yeah,
Yeah, from
great question. Great question. It's commissioning is what we call it. Is like is 90 to 100 days. And so we launch this Sunday. That means just before the holidays. Hopefully, we're going to be switching into science collection mode, right? And that's when we'll start getting the images down or out to the public. There'll be some stuff. So let me back up. We launch, then there's spacecraft commissioning, which is, making sure the spacecraft can steer the way we want it to. All systems are go, things are great there. Then we have our payload uh, alignment campaign, which is the mirrors all throughout the telescope, as well as making sure that our cameras are doing what they're supposed to be doing, our two instruments. And then we do our calibrations, make sure everything's great. And then we can start taking our own calibration imagery, work on that a bit more. And once we're like, okay, this is good to go, we'll move into our science collection phase. But that it takes it depends how getting to L2, it's going to take about that amount of time too. because we have the time to get out there, and time to set things up. It all kind of comes together where we get out there and we're inserted and ready to go.
Very cool. You were talking about the slewing of the. I understand that the Nancy Grace Roman Space Telescope, its ability to quickly slew to targets is going to be its kind of superpower too.
One of them, yeah, no, absolutely. That's a great point. It's almost like we're driving an elephant around and then stopping on a dime and taking no time to settle before taking images. It is a super nimble, massive thing. Also extremely thermally stable. So on your telescope, right, we have an outer barrel assembly that goes around the optics to keep our thermal settings right where we want them to be. You want that because any variation of gradients of temperature, it's going to change the shape of those optics just a little bit, so that space will look different if you have that happening, right? So yeah, extremely thermal stable, as it's thermally stable, like down to the millikelvin tolerance of keeping it, tight, like we're hitting exactly what we want in terms of temperatures. And then in terms of moving around and stopping on a dime, and that's just it. We're surveying everything, right? So that's the name of the game. We want to be able to do it fast so we get all of the data quickly and we aren't just wasting time waiting for things to calm down before we can actually take a science image.
And I imagine for things like supernovae, gamma ray bursts, things like that, it would probably slew pretty quickly if needed to, if something interesting pops up,
With that, and again, wide field of view. So the likelihood that it's already in your field of view is more than if you're looking through a keyhole, right?
Yeah, the footprint looks kind of
Got two
like
things
somebody
working
said
for us.
the imaging footprint looks kind of like I'm old enough, child of the 70s, to remember Space Invaders. It looks like kind of is there any reason that engineering
Yeah.
wise they
Yes.
rather than just be square, why has it got that kind of curious looking shape?
It's a very good question, and good on you for noticing. Right? It's why isn't it a circle? Why isn't it a square? It's got this kind of arc, right? And that it's essentially like the telescope. The overall system design is such that the most pristine target is sort of a what's the word I'm looking for? It's not an ellipse. It's actually an annulus. And so this is
Okay.
grabbing a
Yeah.
section of the annulus as best you can, and always your detectors are square, right? So you have to like make the pixels line up with
Yeah,
the
yeah,
with
yeah.
the complex shape. But that's it. It's like any section of that annulus is the way the optical system just has to be. It's a little bit. It's an off axis between the secondary mirror and the primary mirror, just slightly,
Yeah.
and that creates an annulus, which is like the sweet spot of the imagery.
Yeah,
So
I've built some telescopes, amateur telescopes anyway. So I kind of can grasp that. That's interesting. I've never seen that mentioned anywhere else. Why it has that shape? It's interesting. And
yep,
hey, we actually
good
got this
question.
one. This one got Thank you. This one got named after a scientist, Nancy Grace Roman, the first chief of astronomy at NASA. That's very cool. Um,
Yeah.
okay, well,
If you
I
think
held.
about it, right,
Go ahead.
can you imagine NASA without an astronomy, sorry, can you imagine NASA without an astronomy program, right? And it didn't have one when Nancy Grace Roman came on. She was brought on to set it up,
Yeah.
right? There was a quote that was I essentially she left academia because she saw that she wasn't, it was very unlikely she'd be able to be tenured. And so she thought she'd contribute in this other way, and we are the beneficiaries of that. Yeah, she was the chief of astronomy from the late 50s through the 60s and 70s,
Yeah.
um, and a fierce advocate for putting space telescopes in space, which is quite a crazy idea.
Bear, are
And
you gonna? Oh, go ahead.
or it was then. And yeah,
Are you
no,
gonna
go
be
ahead.
at the? Are you gonna be at the launch Sunday?
Unfortunately, no. I wish I could be in two places at once. I have
Yeah.
the honor of being a part of the launch and commissioning team but I'm going to be here in Maryland for that. And
Okay.
so part of our team's in Maryland at Mission Operations Center here in Maryland, and then obviously a bunch of us are down at Cape Canaveral, and I'm just on the Maryland side. But
I
I get
would
to drive a spaceship, so I can't
That's very
complain.
cool. I would love to be. I've been to several. I was at the Curiosity launch way back in the day, and it's fun to be. But there's a joke in the science writing community that the worst place to cover a launch
Okay.
is at the launch because you're out in a field in the middle of nowhere and you've got your notes and you've got to get back to your
Yeah.
hotel room and get. So actually, sitting here at my laptop will probably be a better place for me to be covering the launch. So, yeah, well, it's I won't keep you any
Yeah.
longer. I know
Yeah.
this was kind of a shuffle to get this
Okay.
interview in at the last minute, but um, Bear, thanks for talking with me, and we'll end the recording here.